guys, today in Passion Electronics, let us try to understand practical application of resistors, and the first circuit I would like to talk about is voltage divider. This arrangement is called as voltage divider arrangement. The beauty of this circuit is that if you are connecting node A to VIN and node B to the ground, then you will be able to generate any voltage which satisfies the condition 0 is less than or equal to V out is less than or equal to V in by carefully varying the resistor values R1 and R2. V out at node C is given by the relation V out equals V in times R2 over R1 plus R2. So if by varying the resistors R1 and R2, you will be able to generate any voltage at V out which satisfies the condition 0 is less than or equal to V, which is our requirement, is less than or equal to VIN. For example, let us try to get V out to be 3.8 volts by supplying V in to be 5 volts. Here V out is 3.8 volts and V in is 5 volts. On solving this equation, we get 0.24 times R2 will be equal to 0.76 times R1. If you choose R1 to be 1 kilo ohm, then it turns out that R2 is equal to 3.17 kilo ohms, which is approximately equal to 3.2 kilo ohms. So if you replace R1 with 1 kilo ohm and R2 to be 3.2 kilo ohms and supply VIN equal to 5 volts, then you will be getting V out as 3.8 volts. The next practical application of resistor is we use resistors as current limiters. Resistors can also be used as current limiters. In the second application is we will be using a resistor as a current limiter. Most of the electronic devices have a factor called as current limiting factor. This is the maximum allowed current that can flow through the device. Else the device gets zapped. So we must ensure that the maximum current through the device is the current limiting factor IF. Say that the current limiting factor for this LED is IF, and we all know that the LED starts to glow only when the voltage across the LED reaches a minimum value called as forward voltage VF. So we must carefully choose the value of resistor R in this circuit, which can be easily obtained by using KVL. For instance, in this circuit we can easily obtain KVL. In this circuit, by applying KVL and Ohm's law, it turns out that the value of resistance which is to be chosen is R equals VCC minus VF over IF. So we have to choose resistance in such a way that which satisfies the condition VCC minus VF over IF. So always remember that LED is always accompanied with the series resistor. Not only LED, but it is case with many other electronic devices. Besides these two, we will also be using resistor as a pull-up resistor. In digital electronics, we have three states. The first is off condition, the second is on condition, and the third is something called as floating condition. This circuit on the left is actually a bad circuit because we have a floating condition here. What this means is that at node voltage A, if there is any stray voltage, the circuit on the left side is actually not a very good circuit because we have floating condition here. At node A, if there is any stray voltage, then the output of the circuit can be undetermined. So if we replace this circuit as shown in the right figure, then our circuit is a stable circuit, because if we open the switch, then the